Okay, so today we're looking at finding determinants of square matrices. And we already did look at this in the case of 2 by 2, so let's just see what you remember. Okay, first of all, remember the notation. The notation is these two vertical lines, look like the absolute value sign, but it's not in this context. But how did we find the determinant of a 2 by 2? It was part of our getting the inverse of a 2 by 2, but
it was AD minus BC.
good. Good. AD minus BC. Alright, so you multiply the diagonal, multiply that diagonal and subtract it. Okay?
Fish.
Yeah, the fish method. So, if we're doing AD minus BC to find the determinant of A, in this case, we're going to have 6, 3 times 2, minus
52.
8 times 6, yeah, 56. So that would give us a negative 50 for the determinant. Remember, the determinant gives us a value, not a matrix. Okay? So that part is review. And that we will actually use, in one sense, in both of the ways that we're going to be finding the determinant of a 3 by 3 matrix. Okay? The 3 by 3 matrix, we're going to learn two methods. The first method is actually kind of derived from the second one. So there's a little bit of a trick to it. But mathematically they're the same value and the same process in the end. Okay? So we're gonna actually calculate the determinant of this matrix here both ways. So A is 4, 6, 5, 3, negative 2, 1, and 0, 8, 7. And in order to find the determinant this first method, the first thing we're going to do is take these first two columns, 4, 3, 0, and 6, negative 2, 8. And we're going to copy them as a fourth and fifth column. Alright? So as you look here, notice this column has A's in it. We copied it over here as a fourth column. This middle column of our original matrix has B's in it. We copied it as the last column. Alright? The reason why we did that is because then, obviously, we could have looked at this diagonal with the original matrix. Alright. This forward diagonal, we call it. This one, though, uses part of one of those columns we copied. So that's why we copied the columns over. Alright, so we have that second diagonal, and then this third diagonal here. We call these ones the forward diagonals because we start on the far left side and we're moving forward with them. We're moving to the right. Okay? And what we're going to do is similar to what we did with the fish method is we're going to multiply these. So A1 times B2 times C3. Alright? Now you may or may not want to copy it down with the A's, B's, and C's. It may be easier once we get numbers in there to understand what's going on. But we're going to multiply those three diagonals and add those values together. Then we're going to start on the far right corner, top right corner, and multiply the diagonals going backward like this. Okay? And we're going to subtract those. So just like on the 2 by 2, where we added the diagonal that was going forward and we subtracted the diagonal going backward, we're using the same concept here with our 3 by 3s. Alright? And if you want, you know, we have like this super school of fish here. Okay? There we go.
It's triple fish.
Yeah, triple fish. Alright. but that's probably more confusing than it is helpful, so we'll get rid of it. Alright. So let's actually see this in action, and if it's still a little foggy as to what we're doing, that will make a little better sense. That's the actual formula. You don't need to try to memorize. Don't try to memorize that. Okay. Don't bother. This keeps changing colors. There we go. Back to gray. I don't know what use that feature has, but there we go. Alright, so you'll notice here I took that original matrix that we saw at the top, and I copied the first column 4, 3, 0 as a fourth column. I copied the second column 6, negative 2, 8 as a fifth column. And now we're going to look at our diagonals. Alright? Now, it's important that as you're writing this down, you try to space your columns out neatly and write everything neatly. That way, when you identify your diagonals, you don't accidentally get something from the wrong column in your diagonal. Okay? So here, 4, negative 2, and 7. 4 times negative 2 times 7 is a negative 56. Then you have 6 times 1 times 0. So we're adding 0. Then you have 5 times 3 times 8. Okay? So that's 120. We're going to add that. Alright, so our forward diagonals are done. Now we'll start at the top right with this 6. And we're going to get our backward diagonals. So 6 times 3 times 7 is, what is it, 126? Alright, now we're going to subtract that though. Okay, because it's a backward diagonal, we're subtracting now. Then we take our next backward diagonal, 4 times 1 times 8, and we're going to subtract that, value 32. And then our last backward diagonal, 5 times negative 2 times 0 is 0, so we're subtracting 0. Okay? I'll write it in there just so you can see we did all three of them. So, now we just have to add everything up together. Okay? 120 minus 126 is a negative 6. Minus 56 is negative 62. Minus 32 is a negative 94. Okay, negative 94. Yes?
What is the determinant of a 3x3 matrix used for?
Well, we're actually going to, one of the things we're going to look at next week is called Cramer's rule. And that's another strategy for solving a system of three equations with three unknowns, or actually any system of equations. And it uses the determinants specifically. That's what we're going to use it for. It is used for other things once you get up into linear algebra or an abstract algebra class in college, but for our purposes, we're going to use it for Cramer's rule. Alright, so does that make sense? Everyone understand what they're doing with that? Okay, good, because here's one for you to try. Alright? We're going to do the same example for both methods, and I'm going to have you solve the same one on your own to practice for both methods. So here we have 2, 1, 5, 6, 3, 8, and negative 4, 7, and 9. Notice I have the vertical lines here, so that is saying find the determinant of that matrix. Okay. remember, start by copying the first two columns as a fourth and fifth column, then work through your diagonals.
哦，那我说错了。啊，等会儿我乘错东西了。我乘错数了，等会儿。我乘错数了。
368.
Yes, 126.
126,
我算错东西了。
338.
338. Well, remember you subtract the backwards diagonal.
这要减，
So
不是
subtract
要加。
Okay.
不听课的后，看到我写错数了。不听课的后。
Oh.
是这样就是乘那个就减。
乘3个不是加3个减3个就是。
Check your arithmetic.
听着，爸爸说的是对的。
Down the negative 4.
So what should be
Okay.
plus 16.
Yeah, minus the negative would be plus 60. Okay, so take a look. How many of you have gotten 126 at this point? Okay,
我又
good
不
number of
举
you.
手了，刚才。
Alright. So, chances are, if you didn't, it was either because you forgot to subtract, or you just did some arithmetic wrong, some multiplying wrong or something. This method tends to be the one that students who like doing the mental arithmetic and can keep track of that in their head a little bit better, okay? I prefer this method because I like doing the mental arithmetic a little bit more. But you have your diagonals. 2 times 3 times 9 is 54. 1 times 8 times negative 4 is a negative 32. 5 times 6 times 7 is 210. And then your backwards diagonals. 54, which we subtract. 112, which we subtract. And then negative 60, which we subtract. And you should get a 126. Yes?
Do you only use this with 3x3?
Yes. Okay, you can only do this with a 3x3.
Can we use it to find the inverse of the?
What?
Can we use it to find the inverse?
No. This is not used to find the inverse of a 3x3. You have to do it the way we had done it with the row reducing. Okay. So any questions about the method or any part here you're not sure of? Anything? Alright, so let's take a look at our second method. We're going to do the same two problems, but you'll see we'll get the same result either way. And I don't care which method you choose, just pick the one that clicks better with you. So that's why we're doing both of them, and then you guys can kind of get a feel for which one you prefer. This one is using what's known as minors and cofactors. Okay? Let me show you the formula but I wouldn't necessarily recommend trying to memorize the formula. Rather, memorize the pattern that the formula uses, okay? So here's our formula. We have the determinant of this 3x3 ABC, DEF, GHI. And you'll notice we've broken it down into one of the elements times the determinant of a 2x2 that's made up of some of the elements in here. Okay? And then we have another element B times the determinant of some of a matrix made of some of those. Alright? And you'll be like, there's no way I'm going to remember how to put all those together. You will once you see it. Okay? These constants here, these elements that we've pulled out, are known as the cofactors. Okay? The cofactors. These matrices are the minors. Okay? Now let's look at how we get those. First of all, notice A is right here. E, F, H, and I are right here. Okay? Now don't anyone say anything for a moment until we go through all three, and then we'll see if you can pick up on the pattern. Alright? B is here. D, F, G, and I are here and here. D, F, G, and I. Then lastly, C is here, but D, E, G, and H are right here. Okay? So can someone explain how we got those minors from the cofactors that we used? Maria?
The ones that are not in the same column.
Good. We use the ones that are not in the same column, and obviously not in the top row either. Okay? So A, we didn't use anything from the first column or first row. That left us with E, F, H, and I. Alright? Now that, especially if you don't have different colored pens, that might be a little confusing on your notes. And it's even more confusing if you actually look at it all worked out. Alright? But I show you this because look at this. If we have A, B, C, D, E, F, G, H, I, and then I do this, look,
It's the same.
AEI, BFG, BFG, CDH, CDH,
The same.
okay? And then minus BDI, minus BDI, minus AFH, minus AFH, minus CEG. Alright? Somebody using this method recognized the pattern and came up with the first method that we had looked at. Okay? That's how these things get developed. People just use the same method over and over again and then eventually see a pattern. Okay? Thank you. So let's take a look at this used on our example problem. Until you get the hang of it, I would recommend actually writing out the matrix 3 times. Okay? And watch what we're going to do. First of all, we use this first element in the first row. So there's our 4. And then we're going to make a minor matrix by eliminating the column and the row that 4 is in. And then all you see left is that minor matrix. -2, 1, 8, and 7. Okay? Then for the second term, remember we're going to subtract. That's the one thing that's easy to forget in this formula. You always subtract the middle one. So we are going to use the 6 as our cofactor, and then the minor, we eliminate that first row in the middle column, and we have 3, 1, 0, 7. Okay? And then finally, we're going to use number 5 as our cofactor. Notice it's back to plus 5. And then for our minor, we eliminate that third column and the first row. And there's our minor, 3, -2, 0, and 8. Okay? Now, we're finding determinants of 2 by 2 matrices, right? So it's back to -2 times 7 minus 1 times 8. Alright, so we have 4 times a -22. Okay? Then it's -6 times 21 minus 0. So 21. Okay? Then we have a plus 5 times
24.
24 minus 0 is 24. Good. Okay? So our final answer here, -88 minus 126 plus 120 equals a
-94.
94. And that's the same answer we got the first time. We just used a different method to get it. Okay? So, some people were asking, why do we have the negative? To be honest with you, I don't remember off the top of my head. I think it comes from the fact that here, your minor was all together in the original matrix, and here your minor was together in the original matrix, but here it was split up. I think it has something to do with that, but I can't remember exactly off the top of my head. It's been
You're always
like
gonna subtract
13
the
years
middle.
since I learned it originally, so. Yes?
Do you always subtract the middle?
Yes, you always subtract the middle one.
应该先把它含软，
Okay. That's just part of the formula.
把它含软之后就果肉。
Okay, so does that make sense?
Yeah.
Is that clear? Alright. Alright, so now it's your turn, okay? I know you know the first method and you may think, oh, well, I like the first method anyways, but try this one, okay?
for
Yeah,
next
find the
one?
determinant.
是。
You should get 126 again. Well, that's what we got the first time.
I can get 122.
Got 122. Minus 56. Yeah, that would be 27 minus 56 would be negative 29. 56. 8 times 7 is 56. Okay. Okay. So we should have 2 times negative 29 minus 1 times 86 plus 5 times 54. So negative 58 minus 86 plus 270 should give us 126. Okay. That should have been the same answer we got the first time. That was the example problem, it's negative 94. The first time you did, the first method you used to do on your own. So. Alright, so what do you think?
I
About
like
what?
the first one better.
Like the first one? How many of you like the first one better? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then that leaves how many? How many like the second method better?
I don't know yet.
1, 2, 3. We have more than 16 in here. We have 19 in here. Who didn't vote?
Others were
I
absent.
did it because I don't know the first
You
one.
didn't? So 13 to 3. That's alright. What, so let's see, we had 20, 34 to 19. As far as people in all 3 classes who like the first method versus the second method, really doesn't matter. It doesn't say anything about you or things. But that's just interesting. Usually it's somewhere around 50-50, you know. Some people like it, some people like one method better than the other, and it's fine.
But it's like 66, 33.
Yeah, it's close to that, so. But hey, the point is though, you need to be able to do it one way or another, okay? I don't care which method you prefer, you'll have to be able to do it one way or the other, okay? And that's all for today.